Alright, so Algebra 2, Chapter 3, practice test. Let's see what we can do with this. It says solve the system by graphing. We have tons of ways that we could do that now. My hope is that you'll know, hey, it's in standard form. I'll use the thumb method. Bless you. Hey, it's y equals mx plus b. I'll use that. Some of you might say, oh, I remember when we did this in class, we used the graphing calculator. So I'll do y equals mx plus b on both of them. But you still have to graph them. You still have to get them on here somehow for your graph. Although I hope yours showed up a whole lot better than mine up there. I can't even see grids. Oh, yours is kind of bad too, isn't it? It's all faded. All right, so I'm going to pick a color, go with the top one, and I realize that one's in standard form. So to graph this one should go super fast by finding the zeros, using the thumb method for that. So if I have a 0 in my x and I cover this up, the negative of something is -1. What's the something? Cover that up. What would you have to put in for y to make that true? 1. So 0, 1 is going to be one of my points. If y is 0, I cover this up, and I realize, well, I'd have to divide by 2. That's going to be a -1/2. Now that could be a problem. Here's why. Those 2 points are going to be really close together. And this grid is really, really bad. I'm wondering if I can turn up the grid on mine. I can't. Sometimes it lets you choose that and make it darker. No, mine's not going to happen. So 0, 1, -1/2, 0. So one of the things I could do is say, if that way is not working real well, maybe I better do some y equals mx plus b. Maybe that would get me a little bit better, a little more space between those two, because I don't draw a real straight line without something to help me out. So I realized this wouldn't take too long to get into y equals mx plus b. What would I need to do if I'm going to get y by itself? Come on, everybody, this is review. Talk to me. What do? Subtract 2x. Y isn't by itself yet. How do I get it there? Divide everything by -1. So then, oh, come on, smartboard. There we go. A little more space. Y equals 2x plus 1. Now, how is that helpful? Because now I know the slope is 2. And so I can come over here and say, yeah, I'd started as 1, and then I'd have to go up 2 and over 1. And that gives me a little bit more space so that my line is a little bit straighter. All right, the bottom one. I'm going to grab a new color. Would you do anything with that one? Make any changes to it? It's y equals mx plus b. I'm not making changes to that. Where does that graph start? Come on, I see you doing it. Where are you starting? Well, fine, I'll just call on people today then. I wasn't going to do that. I'd rather you volunteered. Can somebody tell me where to start this? Green one. Aaron. We've got y equals mx plus b. It's just kind of backwards, Aaron. So we can just flip it around. So where does it start? -2. Oh boy, somewhere around there, I hope. And where does it go from there? Up 1 and over 2. And this would be the time when you hope you've drawn it really, really straight, and you hope you can see a little bit of those grid marks. See if you could come up with a good guess for where you think they hit each other based on that. And then tell your chicken wing elbow partner where you think it is. Oops. What's the ordered pair where you think they hit each other? Much better lines on the test, by the way. I don't know why that didn't copy well on your practice test. I see some people guessing -2, -3. This is a test. I'm not going to guess, right? So two things we can do. We can put the -2 and the -3 back up in both of these and make sure they work. 2 times -2 is -4. -4 minus a -3 will be -4 plus 3, which is -1. So far it works in the top one. 1/2 of -2 would be -1. -1 minus 2 is -3. Hey, it works. Or we do what we did in class. They're both solved for y anyway. And we let Blinky tell us that that's where they're supposed to hit each other. So I had y equals 2x plus 1. And then I had parentheses 1 divided by 2, parentheses x minus 2. Zoom 6. Second trace, number 5, and hit enter 3 times. And Blinky says it's at -2, -3. Now technically, we won't need a graphing calculator for this test, but you're probably going to want one. Yeah, if you don't have one yet, I've got some up on my desk, so why don't you go grab one right now. I'll just stop this for. You have to have it graphed, and we should definitely double check. You're going to have enough time to double check. If you want to double check by putting it back into these two equations, fantastic. If you want to double check by getting Blinky, absolutely, but make sure it's right before you hand it in. And if what you have isn't working in these equations, you graph something wrong. You know, you have to go back and figure out, did I do the slope wrong? Did I do the b-value wrong? What did I do that messed this up? Now, I had cheated and put this big one up here, but I didn't think that was fair, given that you guys weren't going to be able to do that, so I wanted to use the same grid you had. This one says, pardon me, changing gears. Solve the system using substitution. Okay, substitution. That was where we had to get an x or a y by itself and then substitute it into the other equation. Anybody see an x or a y by itself that would be good? Got some choices this time, don't we? But let's all do it the same. That way we'll make sure everybody's following the steps. So do you want to get x by itself or y by itself? First person that speaks gets to pick x or y by itself. X. All right, x it is. And it doesn't matter if you put x equals 3 minus y or if you put x equals -3 plus y. Whatever's easiest for you is perfectly fine. So we're going to substitute in the other equation, the one we haven't used yet, 5x minus 3y equals -1. We're going to put this in for x, 3 minus y. So we'll have 5 times 3 minus y minus 3y equals -1. And we notice, hey, we just have y's left. We're going to be able to figure out what y is. So what would we do next? What are you thinking, Maddie? You seem to be writing a lot. What would you do next? Absolutely. Then it's going to look like that. Yosh, what would you do next? Okay. You're right. We could put the 15 over on the other side by subtracting. Most people are probably just out of habit from linear algebra are going to put these together first. So we've got negative 8y equals negative 16. Silas, what would you do after that? Absolutely. That's going to give me a y equals 2. So then I have to think, am I done? Faith, am I done? No, I still need x, right? So I don't know about you, but my thought would be, where's the easiest place to get x? Oh, wait a second. I've got this great little formula over here. X equals 3 minus y. Cool. So x equals 3 minus the answer we just had, which was 2. Well, that's going to give me 1. And now last but not least, we want to write that as an ordered pair in our little answer blank over there. Again, totally checkable. You put the x in, the 1 in for the x, and you put the 2 in for the y, and you make sure it works in both of those equations. 5 times 1 is 5. 3 times 2 is 6. 5 minus 6 is negative 1. 1 plus 2 is 3. Boom. You know you're right. Taking the test, you give yourself one of these. Yes. Confidence booster. Yes. And you go on to the next one. So that's substitution. Now, here's the problem. If people don't use substitution, if you use the wrong method, I can't give you points for that. So make sure that you're following the directions and you use substitution when it says substitution. Because these two problems are really about, do you know the difference between the two methods that we have? Alrighty, number 3. Number 3 says we are supposed to solve the system using elimination, which is okay because this wouldn't be a fantastic substitution problem anyway because it doesn't have an x or a y all by itself. So then I have to think, is this one good to go? Can we go ahead and add it? Oh my goodness, people are shaking their heads. Where'd you see? What are the opposites? Haley, what'd you see? Grace, what'd you see? Negative 3 and the plus 3. I said Haley instead of Abby. Got it? Stuff coming out of my mouth today. There we go. So the negative 3y and the plus 3y is gone. Oh, this is going to be kind of nice. Look at that. 60. Well, that went fast. X equals 10. Not done, though. Still have more work to do. We have to pick one of those equations which we like better. So let's take a peek up there. Taylor, you like one of those equations better than the other one, the top one or the bottom one? Top one, smaller numbers. I'm with you. I like that one too. So we'll have 2. Our x value was 10. Minus 3y equals 14. Well, that's just a two-stepper. This is 20. So then we'd subtract 20 from both sides. Divide by negative 3. And we get y equals 2. Which would get us almost all of the points. Because what didn't I do yet, Ellie? Ellie, what didn't I do yet? I didn't check it, but I can't check it until it looks like what? Look at our answer from our last one. Yeah, I've got to write it as an ordered pair. Now, Ellie's right. We're going to have time. We should check it. So 10, 2. 10 in here would give me 20. 3 times 2 is 6. 20 minus 6 is 14. That works. 4 times 10 is 40. 3 times 2 is 6. 40 plus 6 is 46. Yes! Yes! way, you already know you've got the first 3 problems right. You've checked them. Everything's going great. So huge confidence booster when you can do that. And then you get to this one, and you get to pick. Solve the system using either substitution or elimination. And again, I would like us to all do this the same way if we can. So I'm just going to pick somebody that gets to pick which method we're going to do this by here. Let's see. A couple of people trying not to make eye contact. Christian, what do you want to do? Substitution? You want the x or the y by itself? X? Sounds good to me. And again, you could put x equals negative 12 minus y minus 12. It's exactly the same thing. So now we have to put that in that top equation. So let's see here. 2, and we just said x equals negative y minus 12. So 2 times negative y minus 12 minus 3y equals 6. Johnny, what would you do next? Yeah, distribute that too. Sounds like a good plan. Sophie, what would you do next? Sounds like a good plan. Jillian Telfer, what next? Beautiful. Looks like so. Let's see. Who haven't I picked on yet today? Jameson. Divide by negative 5. Winner, winner, chicken dinner. Y is negative 6. Kyle, are we done? What do we still need? Oh, the ordered pair. But I only have the Y. Everybody see the good place to get the X? Right here. That's why I like substitution. It's so fast to get the second one. This will go here. The negative of negative 6 minus 12. And basically, that could just be calculator work at that point if you're careful punching it in. But negative of a negative would be a 6. And 6 minus 12 would be negative 6. And then Kyle's right. We want to come over here. X comma y. Before we move on to the next one, what should we really do? Yeah, somebody said check. Yeah, I would. Why not? I mean, it seems like a pretty basic problem. Make sure you've got it right. 2 times negative 6 is negative 12. Negative 3 times negative 8 is positive 18. Negative 12 plus 18, that's 6. Cool. Or, wait a minute. Did I get a negative wrong there? Negative 12 plus 18. Yeah, positive 6. Negative 6 plus negative 6 is negative 12. Beautiful. That's right. First 4 problems. Aced them. Woohoo! Now look at this one. Substitution or elimination, we get to choose. What's everybody thinking? It's not a good one for substitution, right? I mean, the x's and the y's, if we try to get them together, it's going to be pretty ugly there if we get x equals or y equals. So then we have to think, okay, well, 7 and 8. Smallest number we could make 7 and 8 be the same as would be 56. That's kind of big. Smallest number for 5 and 9, what would that be, everybody? 45. Is 45 easier to work with than 56? Most people would say yes. And we've already got a positive and a negative, so let's multiply the top equation by 9 and the bottom equation by 5. And let's see what we get. So 63x plus 45y equals 18. The whole thing gets multiplied by that. 40x minus 45y equals 17 times 5, 385. So far, so good? Not necessarily liking the numbers, but 45 and negative 45. Well, so let's add them together and see what happens. That's going to be 103x. 3, carry the 1. Oh, look at that. Nasty numbers, but it works out nice in the end. Cool. X equals 1. We're not done. So we've got to figure out where we're going to get the other one. That would be top equation or bottom equation. Haley, if you had to do this one, would you use top or bottom to get that second value? Me too. Smaller numbers. Not a fan of 17. So we have 7 times our little 1 plus 5y equals 2. 7 times 1 is 7. Subtract 7 from both sides. 5y equals negative 5. Divide by 5. Excellent. Y is negative 1. Almost done. Almost. What do we need to do? Ordered pair. And since we got the first 4 right, I would definitely check and make sure, hey, I'm on a roll here. 7 plus negative 5. 7 plus negative 5 is 2. 8 plus 9 is 17. Yes, ace in this test so far. Absolutely fabulous. So we've got solving by graphing, solving by substitution, solving by elimination. Then we get to pick on a couple. And then we get to these where we're back to having to graph, having to figure out how to graph these. So, see if you can remember how to graph the top one. Talk to your chicken wing elbow partner. Talk through those steps. Your lines aren't quite as bad on this one, huh? You can see those grids. Excellent. I see some partners talking through and showing each other talking about the dashed and the solid and the shading and all of that. So I'm going to color code this one red. That one is in that y equals mx plus b form, so I'm going to go up to 5. And the slope is the negative in front of the x, so down 1 and right 1. And then that one does have an equals bar, so it should be solid. A little off there as I go to the right. And then I have to figure out if it's okay for me to shade 0, 0. And this is again where we end up with a negative 0, but we know 0 is neutral. You can't have a negative 0. It's just 0. So 0 plus 5 is 5. Is 0 greater than or equal to 5? No, we can't shade down here. We've got to shade up here. go that way. The second one, I know some of you are going to subtract the 2x and divide by 3 and get it into y equals mx plus b. You absolutely can do that if you know what you're doing. But I'm going to do this one with the thumb method. And say, okay, if I have a 0 in x, 3 times something is 15. Ooh, that's 5. That worked out nice. If y is 0, I cover this up. 2 times something is 15. Well, I just do the algebra and divide by 2. 15 halves. And think about the fact that that's 7½ when I go to graph it. So 0, 5 again. But then we have 7½ 0. Right there. And then we check. Is this one dashed or solid? Abby, did you do the second one dashed or solid? Me too. Got an equals bar. I got to be careful because these lines are pretty close together here. And then we'll test a point. Our line does not go through 0, 0, so we might as well test 0, 0. Test 0, 0. 0 plus 0 is less than or equal to 15. Sure it is. 0 is less than or equal to 15. So we're going to shade downward. But then show your chicken wing elbow partner the part that you're just going to go crazy with the shading. So you can show me that's where the solutions actually are located at. So do that extra shading and then show it to them so they can see where you did your shading. If you don't have a partner, tap on somebody's shoulder. Say, hey, is this right? I see lots of little sliver shadings. Like that. Everybody agree? That's where it is. That's where it is. All right, let's go on to this one. That's just y equals mx plus b again. So color code in that one is going to be green for me. I'm going to go down 5. What do we do for a slope? Come on, you've got to be feeling more confident now. You just did that last one right. Down 1, right 1. Just use slope backwards there. So dashed or solid, everybody? Solid? Yeah, has an equals bar. Go ahead and test 0, 0 in there and let me know if we should be shading towards 0, 0 or not. Couple people nodding yes. You agree? Yeah, 0 is bigger than -5. All right. Change colors. Now we got some memory banks time. You guys were really good at graphing these. This is an absolute value. Tell your chicken wing elbow partner what an absolute value graph looks like. These are V's. Tell your partner where the vertex of this one is. Where's our vertex? Somebody has to be confident. Nobody's confident? -3, +1, left 3, up 1. Yep, it's always the one that's with the X that we have to think opposite of. So there's my vertex. It's supposed to make a V, but I don't know where yet. So what do I use to figure out how that's supposed to look? Michaela, what can I use? We've got our vertex right here, but I don't have a V yet. I need to know how to get at least one part of my V. What should I use? -3, 1. There's one number I haven't used here yet. Do you remember what the -3 is for? The slope of the right side of the graph. Yeah, so we're going to go down 3, 1, 2, 3, and to the right 1. We can do that a couple of times. And then you can use slope backwards to get the other side. So down 3 and left 1. And then we need to know whether or not this should be dashed or solid. What do you think, everybody? Dashed. We finally have a dashed one. Doesn't have an equals bar. Now this one says y is less than, which means we have to shade down. Well, since up would be up here outside of the V, that means down has to be inside of the V. But again, you could test a point. You could try 0, 0. Zero plus 3 is 3. The absolute value of that is 3. Then we'd get -9 plus 1. 0 is less than or equal to -8. We know that's not true. So if we can't shade 0, 0, we have to shade inside. All right, now find where that really, really dark shading should go. Itty bitty little piece again this time, right? Yeah, we've got that. So that's graphing the solutions, which led to what we have to do in the next ones, which is our graphing a system of constraints. Let me check the time here. Let's stop there for today. Then we're not doing too much since there were 3, 4 people absent today. Let's stop there. So we'll do the feasible region, word problem-y stuff. Oh, you know what? Let's at least do number 9. Let's go to number 9. Skip that one. Because this one's in kind of an awkward place. Let's do one of these. You have $5.55 worth of change in your pocket. You realize that you only have dimes and quarters in your pocket. You count out 33 coins. How many dimes and quarters do you have? Anybody see a total? 555, yeah, right away. So that one's about money. What else in that information was something about money? Dimes and quarters. So we know that dimes are 10 cents each, and we know that quarters are 25 cents each. So X is going to be my dimes, and Y will be my quarters. Has to be another total. We can't solve this if we don't get another equation. What was the other total? $33. Yep, and Johnny's saying we're just going to have to put X plus Y, because they didn't say you have twice as many dimes as you have quarters, you have 3 times as many quarters as you do dimes. We don't know. So now we want to pick the easiest way to do this problem. And the easiest way to do this one is substitution, because we can get the x or the y, bless you, all by itself pretty doggone fast. So I think I'm going to subtract the y from both sides. And then I can substitute that in for x. And yeah, I can hear the lids coming off the calculators, because with the decimal things, we usually want to use a calculator for this stuff. So 0.1 times 33 would give us 3.3, but let me put that up there. So 3.3 minus 0.10y plus 0.25y equals 555. Then we combine like terms. If you have 0.25y and you subtract 0.10y, it's like a quarter minus a dime. That would give you 15 cents. So 3.3 plus 0.15y equals 555. Well, now we're 2 steps away. We need to take 555 and subtract $3.30. 0.15y equals $2.25. Divide by 0.15. And we get 15. And then I just have to figure out 15 what? Was that my dimes or was that my quarters? That was my quarters. So 15 quarters. And now since it's a word problem, I just think, well, they said I had to have a total of 33 coins. So I need 33 minus 15, and I've got this done. 18 dimes. Definitely checkable. Take 18 times 0.1 plus 15 times 0.25, and make sure you've got $5.55. Now, the reason I wanted to do that one was because when we start with number 8 tomorrow, you might have forgotten how to set those up. You'll be able to look at this, and then we'll do number 10, and that'll help you out a lot with that problem. Okay, that's a better place to stop, because then we won't have a tremendous amount to do for tomorrow. I am going to give you the review assignment. The review assignment is the only one you're going to get. So if you wanted to do a little bit tonight and a little bit tomorrow night, that might be a good idea. Instead of doing all of it and then not having anything to look at or review tomorrow night before the test. And I just figured out why it was so quiet in here today. Simon is the usual talker, and he's gone. Oops, got a hold of somebody's backpack there. There we go. So, for those that are watching the recording, I just gave out little slips. Let's say the Chapter 3 review is page 146, number 31 and 41. Page 160, number 13, set it up only. Page 183 to 185, 1 through 15, 17, 19, 20, and 22, but for 19 and 22, set up only.